Jai Hind everybody, my name is Nandita Goyal and I am working as Assistant Professor in Department of Information Technology at AKGEC Engineering College, Ghaziabad. So today I will be discussing the topic event handling in Java. So the topics that I will be covering today include what do we mean by events, what are the different types of events, then in Java we have delegation event model which is actually used to handle the events. So what do we mean by this model? How is event handling done? Then what are the various event classes and listener interfaces which are available in Java for handling of events? Then at the end we will be taking an example of the Java code for handling the events. Now what is an event? If I talk about an event is nothing but whenever an object changes its states from the previous one, we call it as an event, or whenever an object changes its behavior, that is a event. Like suppose I have a form or a GUI in which I press a button. So pressing that button basically changes the state of the previous object to a new object. Dragging a mouse, this is again an event because it is changing the state of the object. So changing the state of any object is actually known as an event. We can have different examples like clicking on the buttons, dragging the mouse, or clicking the mouse, releasing the mouse. All these form events. Now in Java we have a package known as java.awt.event. This package provides all the classes and listener interfaces which are actually responsible for handling the event. So whenever we are writing a Java code, we need to import this package to use event handling, that is java.awt.event. Now to classify the events, we can classify the events into two categories. One is known as the foreground events and the other one is known as the background events. So what is the difference between a foreground event and a background event? If I talk about a foreground event, it is nothing but it is actually generated when a user interacts with some GUI. Usually an interaction with GUI by a user results in a foreground event. Like suppose a user has a GUI and he is clicking a button or scrolling the scroll bar or moving the cursor. All these will result in events which are known as foreground events. If I talk about background events, these events do not require any interaction of users. These are usually generated by something like if there is a failure in the operating system, or there is an interrupt, or there is some operation completion. So basically the background events do not require any user interaction to generate these events. This is the basic difference between a foreground event and a background event. The foreground event will always require a user to interact with a GUI that will finally result in the generation of an event. But if we talk about a background event, it doesn't require any user interaction. They are automatically generated by the system in the background. Like any failure in the operating system is one of the examples of a background event. Now coming to event handling. What is event handling? Event handling basically means that I should be able to decide that what should happen when an event occurs. So this is something which is known as event handling. It is basically a mechanism which is used to control the events and enables us to decide what should happen as soon as an event occurs. Now if I talk about Java, in Java the events are usually handled with the help of a delegation event model. So this delegation event model is used to handle the events in Java. This model consists of two main things, one sources and the other are listeners. Now what are these sources and listeners? So as the name says, sources are nothing but actually these are responsible for generation of any event. So whenever there is a source, it can generate an event. So whenever this source will generate event, what will happen? We need to handle this event. So this event which is generated by the source can be handled by something known as listener. This listener is nothing but an interface which will actually be responsible for handling the event generated by the source. So, whenever we will talk about a delegation event model, we will be talking about two things, that is the sources which will be responsible for generating the event, and listeners, which are nothing but the interfaces which will actually handle the event. So, sources are the sources, that is events are generated from the sources. There are various sources like buttons. Buttons are basically pressed to generate an event. Then we have something known as checklist, through which you can select whatever items you want. Then we have list, menu list, choice, scroll bar, text components, windows, and all these are basically the sources which can generate the events. If we talk about listeners, listeners are usually used to handle the events which are generated from the sources. So, each of the listener is nothing but an interface that will be responsible for handling the events. Now, if I talk about the sources of events, then we have a number of sources which are responsible for generating the events. So, we will be discussing them one by one. Like if I talk about a button, so how an event is generated by a button? It generates the events when a button is pressed. So, the pressing of the button is responsible for generating a event. If we talk about a checkbox, we can select or deselect the items with the help of a checkbox. So, whenever we select or deselect the items with the help of checkbox, an event is generated. If we talk about a choice, then choice is again used to select or change the choice for a particular item. So, whenever this is done, an event is generated. Usually with the help of a checkbox, we can apply multiple selections, but whenever we are making a choice, it is used for a single selection. So, this is the basic difference between the two, but every time you check or uncheck any of the sources, that will generate a event. Now, list, we have a list. So, it generates action events when an item is double clicked. That is, whenever you select or deselect the item from the list by double clicking the item, it always generates a event. So, this is another source which can generate the event. Now, we have something known as menu item. It generates the action events when a menu item is selected. That is, it generates an item when we click on the menu item. That is, from the menu item we can again select or deselect the items. So, this will generate a event. Scroll bar usually generates a adjustment event. This is because whenever we move the scroll bar, the adjustment value changes. So, whenever there is a change in the adjustment value, this generates a event. So, whatever events are generated by the scroll bars, they are due to the adjustment changes, that is the changes in the adjustment value. Next, we have text components. This text component generates an event when a user usually enters a character in the text box. So, whenever there is an entry of a character or text in the text box, the text component generates the event. Then we have another source for generation of event, that is window. So, this generates window events whenever the window is activated, or we close the window, or we deactivate the window, or we open or quit the window. So, any change that is made to the window, it will generate a event. So, we have a number of sources which can generate the events like button, checkboxes, choice, list, menu item, scroll bar, text components and window. So, whenever these sources will generate any event, that event is to be handled by using some listener interfaces. So, we will go into the details of how those are handled. So, now to handle the events generated by these sources, we have a number of event classes and listener interfaces. So, with the help of these listener interfaces, we'll actually handle the events. So we will be discussing one by one that what all event classes we have along with the listener interfaces and then the description. The first event class is a action event class. So for this particular class, we have an interface known as action listener, and this basically indicates that the component defined action occurred like a button click. So the button will be included in the event generated by a button will be handled by action listener interface, or even an event which is generated due to selecting an item from the menu list, that will also be handled by the action listener interface. So for button and menu list, we have our action listener interface. Now moving to the second event class, we have adjustment event class. Okay, and the interface over here is adjustment listener. So whenever there is a event which is generated due to a scroll bar, because a scroll bar changes the adjustment value due to which the event is generated. So whenever the event will be generated by a scroll bar, that will be handled using the adjustment listener interface. Next we have component event class, and the interface here is component listener. So whenever there will be a change in the component, that we are going to change the size, or we are going to change the visibility of the component, the event will be generated. So this type of event which is due to the change in the component size or visibility, it will be handled by the component listener interface, and the event class for this is component event class. The next one is container event class, and the interface for this is container listener interface. So whenever a component is added to a container or removed from a container, it results in the generation of an event, and such type of event will be handled by the container listener class, container listener interface, and the class for this is event class is container event class. Next we have a event class known as focus event, and the interface for this focus for this class is focus listener. So whenever there is an event which is generated due to the change in focus, like we focus in or focus out, or there is some blur in the object, then at that time an event will be generated which will be handled by the focus listener interface. Next we have item event class with interface name as item listener. So here an event that indicates whether an item was selected or not. So if an item is selected or item is not selected, this will result into a generation of an event which will be handled by the item listener interface. Next we have key event class, and the interface name is key listener. So whenever an event occurs due to a sequence of pressing of the keyboard or releasing of the keyboard, and that time the event will be handled by the key listener interface. This means that all the events which are related to the pressing of the keyboard, those will be handled by key listener interface. Next we have mouse event, and we have two interfaces in this, that is mouse listener interface and mouse motion interface. So we can use any one of these, and these are basically used to handle the events that occur due to user interaction with the mouse. Like whenever a mouse is clicked or released, all the events that are generated due to the clicking of the mouse or use of mouse, those will be handled by the mouse listener interface or mouse motion listener interface. Next we even have a mouse wheel event, and the interface for this is mouse wheel listener interface. So whenever there is an event which is generated when the mouse wheel is dragged or rotated or moved, the event which is generated due to it, that will be handled by the mouse wheel listener interface. Next we have a text event class, and the interface for this is a text listener. So whenever an event is generated when a user changes the text object, whenever a user tries to enter the character or text, so that will result in an event which will be handled by the text listener interface. Last we have a window event class with the interface window listener. So whenever there will be a change in the status of the window, at that time whatever event will be generated, that can be handled using the window listener interface. So these are all the event classes we have in Java, along with the interfaces through which we can handle a specific type of event. Whenever we want to perform event handling, we need to register the source that has generated the event with the listener interface. So for registering the source with the listener, we have different classes which provide the registration method. The syntax for this is we'll use add type listener. So here this type represents the type of event that is going to be generated, or the event we want to handle. For example, if we talk about a key event, that is an event which is generated due to pressing of the keyboard or releasing of the keyboard, in that case how we'll be registering that source? We'll be using add then key listener to register. Here this type is basically indicating the type of event. So since the type of event was a key event, which interface we'll be adding? We'll be adding a key listener interface. So this will register the source to the listener interface. The second example which we have for a action event. Action event is basically generated whenever we are trying to click a button or we are using a menu list. So for both of these, we have to register the source with the action listener interface. So we'll use add action listener, which is the name of the interface, to register. So the general syntax for this is add type listener, where type depends upon the type of event which we are trying to handle. Now for all these interfaces which we had already discussed, there are certain methods which can be used to handle the events. So if I talk about this action listener interface, it defines one method which is used to receive the action events. The action events are the events which will be generated due to clicking of a button or due to a selection or a deselection in a menu item. So the method which is available for this is void action performed. Now next we have a adjustment listener interface. So it again defines one method which is used to receive adjustment events. This is basically used when we are making use of a scroll bar which is generating the event, that is the adjustment value will change. So the method here for this type of interfaces, void adjustment value changed. This is the method which is available in this interface and which can be used to handle the event of adjustment type. Next we have a component listener interface. It defines 4 methods to recognize whenever a component is resized. That is, we have a void component resized method. Then whenever a component value is, whenever a component is moved. So another method which we have is void component moved. Then whenever a component is shown, for this we have a method known as void component shown, and whenever a component is hidden, for which we have the 4th method, that is void component hidden. So altogether for component listener interface, we have these 4 methods which can be used. Next is the container listener interface. So the container listener interface defines 2 methods which are used to recognize when a container is added or removed. So whenever a container is added, we can use the method void component added, and whenever a component is removed, we can use the method void component removed. So these 2 methods are used in the container listener interface. Now coming to the focus listener interface, it defines 2 methods which recognize when a component has gained the key focus and when a component has actually lost the key focus. So for gain we have void focus gained method, and for lost focus we have void focus lost. So we have these two methods in focus listener interface. Now item listener interface, it defines one method which is actually used to recognize when there is a state change in a item. So for this we use only a single method, that is void item state changed method. Then we have key listener interface, which actually defines three methods to recognize when a key is pressed, when it is released or typed. So for all the three things we have three different methods. The first one is void key pressed, the second one is for key release, so it is void key released, and whenever a key is used to type, for that we have a void key typed method. Next, for motion listener. For motion listener interface we have five methods which are actually used to recognize when a mouse is clicked, when a mouse is clicked, or when we enter a component or when we exit a component, whenever the mouse is pressed or mouse is released. So we have five methods for all these five functions. The first one is void mouse clicked, the second one is void mouse entered, third one is void mouse exited, whenever we'll exit a mouse, then void mouse pressed and void mouse released. So all these five methods we have for mouse listener interface. The next one is mouse motion listener interface. So this defines two methods which are actually used to recognize when the mouse wheel is moved or dragged. So for dragging of the mouse wheel we have the method void mouse drag, and for moving of the mouse wheel we have another method which is known as void mouse moved. So we have a total of two methods in the mouse motion listener. Then for text listener we have a single method which is used to recognize when a text value gets changed. So we have a method void text change. So now how the flow of the event handling will go. First, the user interaction with a component is required to generate an event. Always a user is going to interact with some component, only then an event will be generated. The object of the respective class is created automatically after the event generation, and it will hold all the information of the event source. After this, the third step will be this newly created object which has been created in step 2 will be passed to the methods of the registered listener, that is the methods which we had just discussed, and then these methods will execute and return the final results. Now to apply event handling, we have a total of 3 approaches through which we can handle the events in Java. That is, we can handle the event within the same class in which we are generating the event. Then we have a second approach in which we can generate an event in one class and then handle it in the next class, or we can even use an anonymous class for generating the event. These anonymous classes are the local classes which are used to optimize the code which you are writing. So we can use any of these 3 approaches to handle the events in Java. So now we will be discussing an example in which we will be trying to handle the event which is generated. So here the interface that we will be using for event handling is a action listener interface, because we will be using a button click for the generation of event. So to start with the program, we have imported 2 packages, that is java.awt and java.awt.event, which is a package for event handling. Then we have a class known as aEvent, which is actually extending the class frame and then implementing the interface action listener for event handling. Within this class, we define a text field as TF, and then we have the constructor aEvent for this class. Now we create the components of this class. So we need to create a text field. So we have used this TF is equal to new text field to create the text field, that is to create the component text field. Then TF dot set bounds, we have given the x coordinate for this text field, that is 60, then y axis, and then width and height for the text field. Now we have added another, we have created another component, that is button, because we will be generating the event with the help of button, and for this button also we have set the bounds as 100, 120, 80 and 30, that is the x axis, y axis, and then width and height. After this, we will be registering the listener, which was an important step. So, for registering the listener interface, as we know, we will be using which method or which syntax? Add, action, listener, and this. Here, this keyword is used for passing the current instance of the object. Now, after creating the components, we will be adding the components, and then we will set the size, layout and visibility of these components. So, we have added the button because with add B, then added the text field. Then we have set the size 300, 300, set the layout, and we have set the visibility. So, in this piece of code, we have added the components, set the size, layout and visibility. Now, we have this method action performed for action listener interface. So, we have defined this method as tf.setText welcome. So, this basically means that what we are trying to do, whenever the button will be clicked, we are trying to have the word written welcome in the text field. This is how we have handled the event generated by the button using action listener interface, and whenever the event will be generated, it will be handled by this word welcome will be shown in the text field. So, now we have created this main class and we have completed this code. So, now what will happen, we will get this as output on our screen, and this is the button where we had written click me, and this is the text field. So, whenever we will be clicking this button, this will generate a event, and the event in turn will show this word welcome in the text field. So, this is how we have handled the event within the same class in which we had generated the event. In the same class, we have even handled the event. So, this was the code for event handling. Thank you.